calculator. But there was this old form, one of the things that they still talk about, it's called change of base formula. For example, if you have the log base 4 of 25, and let's say that you don't have a fancy calculator. Oh no, what do you do? You change base. Oh no, don't be afraid, Caleb. We are here to support you. We care about you and your knowledge and your well-being. Look at all these fabulous prizes.
Okay, are you like imitating someone?
No, she always talks like that last year.
Dang.
So
She was like,
what happens here is they had to come up with some way of doing different logarithms before, normal calculators. And what happened was back then, calculators were all written out in a base 10. And it was all just press buttons and go. Well, they developed a way in order to change your bases if that was the case. There are still calculators that are strictly base 10, like scientific ones. I don't think you can change your base on those, but most of the, I think just about every other graphic calculator that you've ever had will always be able to change the base. Basically what happens is, in order to do this, if your calculator doesn't allow you to change the base, is you take the log of 25 divided by the log of 4. That's all that is. It is straight calculator stuff. The calculator is written in a standard base 10. So if you don't see it written as log base 10, that just means it's implied as a base 10. So back with the old, if you had like, in chemistry, you might have had to have done this. Maybe. Yeah. So if you had just like the old multi-view calculator, and you had to do your homework, you're like, oh no, I can't do it, I don't want to change base. I can actually go in my calculator, type in the log of 24 or 25, hit enter, divide that by the log of 4, and hit enter, and I get, or if I had my fancy calculator, as soon as I hit the newer calculators allows you just to hit the button. I think your calculator, as soon as you hit log, it wants you to type the base in. So. New calculators, it's not a big deal. It's already done for you. It's the same answer. So. Just wanted to show that to you because sometimes there are things that if you had to simplify out, you can simplify some logarithms from here. So.
That was 6 pieces.
Let's use 6 times. All right. Just wanted to remind you of that. Most of the stuff I want to spend time on is, this didn't clean up at all. What I want to spend the most time on is this stuff. The product properties, the quotient properties, and the power properties of logarithms. And I realized that these didn't clean up as nice, so I'll just write them down. So what happens here, if you have log base A of 2 things, U and V, we'll write that. When you take the log of 2 things being multiplied together, it is the same thing as saying the log base A of U plus the log base A of V. You can split them apart. That was one of the properties. Conveniently called the product property because you are multiplying.
I mean,
Quotient property is the log base A of U divided by V. Well, that's just when you're subtracting. And then the last one is the power property. Log base A of U to the, did I use N? Yes. Let's just drop the exponent in front of the log. we have those three very, very simple properties. I'll write them up on the smart board too here. Product or exponent property? Power property. I was going to get it right actually. A power property. So you've got product, quotient, and power. And basically it's going to allow you to do rewrites. It's going to let you rewrite exponent, rewrite logarithms as multiple logarithms. And a lot of times you'll be able to simplify them as you go. For example, just for fun, log base 10 of 3x. That's the exact same thing as saying log base 10 of 3 plus the log base 10 of x. That's what that means. That's what these properties allow you to do, split them apart. Because a lot of times when you split them apart, you're going to be able to simplify things out. Remember, like log base a of a is 1, log base a of 1 is 0, things like that. One coffee. It's like 70 degrees.
I just don't talk about it.
I don't know. I didn't get a chance to drink it all this time.
Mr. Bushel brings in like,
Let me show you an example. So if you want to rewrite a logarithm, what I want to do here is rewrite the logarithm so that I can simplify it. Okay. Which means I have to remember a couple of things about exponents. I have to remember a couple of things about radicals. And how to rewrite some stuff. Do you-
Wait, isn't wouldn't it be the same as like 5?
5 to the 1/3, very good. Yes. Remember, when you have your nth root stuff, this is where some of these nth root things come back in. Your nth root. Your nth root of x is x to the 1 over n. So you could rewrite this as log base 5 of 5 to the 1/3. Now, using one of these properties, I'm going to put it in front. Very good. Rewrite that 1/3 out in front. And what's log base 5 of 5? 1. It's 1. So this is 1/3 times 1, which is 1/3. Yeah, don't forget, the two properties that are going to show up pretty often are going to be your log base a of a is 1, and log base a of 1 is 0. Those two show up pretty often, okay? Those two will show up pretty often with these things. And that's how you would simplify that logarithm without really having to do much work. Okay. Let's try and do another one. Let's do an expand one. I want to expand that. What I mean by expand is I'm going to write it as multiple logarithms. If I want to condense something, I'm going to take multiple logarithms and write them as 1. Expand. Bigger. Condense.
Smaller.
Make smaller. SMRT.
I never understood that until now.
Oh my goodness gracious.
How do you not know that what that stands for?
I know what it's. I know what it's.
What's it
Wait,
from,
it
Jenna?
stands for
I don't know.
something?
Simpsons, isn't it?
The Simpsons reference.
I don't watch The Simpsons.
Watch it. I used to when I was little, but I
I haven't watched it in 15 years.
So my
It's
mom
not good.
never wasn't allowed to watch
Listen,
it.
why you working?
So if I'm looking at this, how many parts? How many parts are there of this logarithm? 3 of them. There are 3 parts. Everybody see that? There's a 5, an x, and a y. So how many logs should I have?
3.
3 of them. So I'm going to rewrite this out as 3 separate logs. Log base 3 of 5. What do I do next?
Plus.
Plus, good. Log base 3 of x squared plus log base 3 of y. Is there anything else that I can do?
Yes.
What?
You can take the 2.
I can take 2, put it up front here. Could I have done that right away? Absolutely, absolutely. I'm just doing the long way to see if you guys remember any of this stuff. You're done. What's up?
Remember last year when I asked you to tell me expand how when you wrote it like across the entire page and you're like, there, it's expanded and I'm so angry.
That was great. Yeah, can you simplify any of that?
No.
Now, if it was a log base 3 of 3, you could, but it's not, so you can't, so you won't. So you don't. Sir?
Would the order matter at all?
No, it doesn't, because does the order matter when you're adding? Does the order matter when you're multiplying? It's usually just gone right down the line. It's usually I just said one after another. All right, let's try condense.
Wait, the first 2 things that we did was the power. That was power.
Oops, I forgot to do. 1 second.
I answered my own question,
Oh, okay.
I think.
Let's condense. If I'm condensing, it means I should finish up with how many logs?
2.
1.
1.
Log
It's always
x squared.
It's already 2.
What's that?
No, x plus 1.
So you break it into easier parts. First one you have 1/2 log of x. That means what? We know we're going to have a log of an x squared. And that's going to be, not x squared, excuse me, x to the 1/2.
Oh, that was my
X to 1/2, or can I write it as x, square root of x? Does it matter? Am I
That's
gonna,
what I meant.
is it okay if you leave it to the 1/2?
Yes.
It's okay. And to be honest, I really don't mind. I think the book might actually write it as a square root or a cube root. But if you're condensing things, if you want to leave it with the exponent power, that's okay. It's not that big. And then what do I have to multiply that to?
So, 1. 3. X plus 1.
2.
Cube. Okay.
Oh, okay, good.
This part, if I know I'm going to wind up with, I'm condensing, I'm going to have 1 log. My base here is 10 because it's not written down. I have 2 parts that are being multiplied together. I'm going to have some value of x times this x plus 1. This one has an exponent of 1/2. This one has an exponent of 3. That's what we're doing. And it's breaking it apart. Okay? You alright, Coca? Okay. You've been too quiet the past few days. I'm worried about you.
She always is. I'm almost dog.
No. Oh yeah, then catch it up. I had duct tape. Man.
Yeah.
Oh, I thought he was at the door.
No, like, forgot about this. Yeah.
Shout out some more.
What, 5 minutes later? I forgot about this.
I really have.
You were there, Cameron?
Yeah.
I wish I had
You what?
Oh, I remember that. You said that.
Oh, yeah, yeah.
What's the over under? She's at 2 right now. At 2.
I did that with those If you would stab.
Oh, no, yeah.
You're just gonna swim from now. Definitely blowing out swimming. Actually, one of the worst things I ever did when I swam, the old touch pads used to be like panels of like aluminum, and like aluminum siding, you've got those little slits in between. And when I did a foot turn, my foot went right through them. It slit my foot, sliced the whole bottom of my foot, giant gash. Swimming, contact sport. Nice.
That would be fun.
She gets Tommy John for moving her head on. We don't need to laugh at your misfortune. It's kind of funny. All right, so we're going to condense this one again. How many logs should we wind up with? 1. What's the base of said log? 2. Okay. Now, what I'm going to do is work on the interior portion first, because we know that this 1/3 is going to be out here after we still mess with this stuff. On the inside, what am I going to wind up with?
Log x squared plus x.
Do you have to write it like that, though? No. Just write it as x plus 1. Okay. And then what do I do?
Put brackets.
Put brackets around it to the 1/3. Good. So you can get log base 2 of x plus 1 to the 3rd. What's that?
Oh, x squared plus x.
No, it's okay, but when you're condensing it, you don't have to go that separate, because you're just breaking it into what it was. I mean, you're not wrong. I'm not going to say that's wrong. I think even the book would write it as this, though. Log base 2 of the cube root, and they might have done it as x squared plus x. That's fine. Or you can say the cube root of x times x plus 1. That works also. All 3 of those answers mean the same to me. Okay? There's no one that's absolutely perfect. So when you're given those exponents that are fractions to them, you're talking fractional exponents, it means you have nth roots. It's not that big of a deal if you don't write it as the 4th root, the 3rd root, cube root, square root, things like that. It's not a big deal. You can just leave them as exponents. Pretty much. All right, let me see if you can simplify this. Let's rewrite this so that you can simplify it. Some very similar stuff was like that. Oh, you from last time? Yeah, there was a couple inverse ones, but that was.
Yeah, I didn't know how to do it. I mean, was
It's just
there
easy.
just, I think it was
It's just
like,
easy
it's like
natural
row in like an
Oh, it
X
was?
and then.
Yeah. Now, think about the properties that we have. We have that log base a of a is 1, and log base a of 1 is 0. 8 is a composite number. Do you agree?
Yeah.
It's 2 to the 3rd. But look at what your base is. Your base is base 4. So, could I rewrite this as log base 4 of 4 times 2?
Yeah.
Which means you could write this as log base 4 of 4 plus log base 4 of 2. What's log base 4 of 4? It's 1. So this could be rewritten as 1 plus the log base 4 of 2. Now what you were saying is it's 2 cubed. That's a great example for if it was what is log base 3 of 8. Because then you can say that is log base 3 of 2 cubed. And then the bases drop and you can write it and go to that. And that's what you were thinking of, right? Okay. Well, we'll come back to those things when we do equations next week. And the equations, oh man, they're fast. They're so simple. Okay. To be honest with you, the stuff that I'm going to have you guys work on tonight is basically all logarithms. Condensing, quick simplifying, expanding. Tomorrow we'll spend a little bit more time with the natural logs. The natural log stuff here, it's all the exact same properties, but it's using natural log. And you guys haven't worked with natural log a whole heck of a lot, so it just looks different. That's why I wanted this, we'll spend more time on that tomorrow, and I'm just going to kind of say call it on this. And we can do it today, but why rush it? So let's do this.
That's why you're not very.
Good eyesight.
So on 3-3,
You look like Jackie's looking
I am. They're from that.
Is it the question or the option?
no, I'm totally, we're changing this up, because there's some things on there you had really no need to use at all. Now,
Whoa.
if you give me a second to read this to you,
No. When you see 39 through 78.
This is all log problems, so just do the ones that say log.
that's all it means.
Really?
Yeah. So if you think about 39 through 78 is a total of what? How many numbers?
A lot.
Too many.
Well, if you take 78 and you subtract 39, how many do you get?
39.
Half of those are log problems.
So.
All you get is 39. Oh, 9.75? Okay. This is what my calculator told me. So did you put in? I did 39. Oh.
So what I basically want you guys to work on tonight are just all the logarithm problems. All right, it's the first. Correct. That's what that is.
In the directions or
In the problems, and I'll put it up here in a second. I'll
what
show.
about the natural?
We haven't talked about it.
Have you ever done?
Tomorrow you'll do the same ones, but yet you'll see.
All right, Jen, you.
As far as what the problems will look like, I'm pulling it up right now.
I didn't want this to do.
Going to change that. Did you write packet on there?
No,
Yeah, because it was a packet.
I did it yesterday.
243.
It's a packet though, not a word.
So these first 6 or 7 of them, can you rewrite and find the exact without using the exponent? So it's log base 3 of 9. So that's going to be log base 3 of 3 squared, which is 2.
No, don't show it.
Things like that. Okay. But as you look at the other side here, it's starting at 39. It says to expand, and then on the next page would be condense. Log base 4 of 5x. Well, that's going to be log base 4 of 5 plus log base 4 of x. And you go through these things, and then you get to some of them that have, on the next page, they talk about condensing. And obviously some of them are natural logs, some of them are logs. So here it says log base 4 of z minus log base 4 of y. What would that be? Log base 4 of z over y.
Z over
Yay, math. Okay. One thing I would suggest, when you get into some of them that look kind of weird with all the different exponents and roots and stuff, if I get into, let's see, number 56. If I get into 56 here, I think it's log base 2 what happens here is, if you look at it, you have two things in the numerator, all being subtracted by one thing in the denominator. When this happens, you have to throw parentheses around the stuff that was in the numerator before you hit the subtract part. It was log base 2, right? I just confused it. So what you would get here is log base 2 of the square root of x plus the log base 2 of y to the 4th, all subtract the log base 2 of z to the 4th. And then you can move your exponents around. If you just wrote it as multiply or add and then subtract without the parentheses, you're not putting it all over the z. Does that make sense?
You need help or something?
That started off as a scary screen. I was kind of scared. I was like,
Is it June?
I will.
No.
they're not gonna go
It's not even
away.
January.
That's what the answer would look like then, okay? Throw it in parentheses and break it apart.
Wait, you can't put this in your calculator.
No, you can't.
I just tried to. We're just like, it would be variables. Okay.
What do you expect? I don't know.
Okay?
Don't erase it.
Okay.
Wait.
You're done.